Hello, 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 everyone. You guys should be able to hear me out there. I see you guys out there in chat saying hello. Dylan, Travis, great to see you guys again. Rob, also over in the UK. Rob, what time is it where you're at? It's probably already Christmas Day, isn't it? For the rest of you out there, I see you guys. We'll give this a few minutes. I saw some people trickle in, trickle out. As always, you guys know I am Fusion Phil here over at jitcadcam, and welcome back to another Free Support Friday. Super pumped that today marks our 10th Free Support Friday. I don't believe it's 10 consecutive weeks in a row because I did take Thanksgiving off. However, this is letting me know that you guys do enjoy this and everything is going good. Chrisnell, hello, how's it going? Rob, it's only 7 p.m. All right, that's not so bad as it's 1 o'clock here in the U.S. The rest of you guys also, hello, hello, hello. I don't have anything planned today to kick this thing off. However, if you guys at any time have any suggestions or things you want to see or what you want me to progress through, feel free to let me know. In the meantime, as always, I'm going to go ahead and do the ceremonial Buy Me a Beer program. If you guys like what you see and you want to support what we do have a Buy Me a Beer option for $3. However, I'm not going to drink the beer on stream, but I am going to crack open this energy drink that just exploded. So give me a moment here while I clean this big old mess up in front of me. All right, we're back. Technical difficulties as always. Matt, hey, how's it going? I see you out there as well. I don't know how this thing just exploded all over my brand new mouse pad that I got, but nonetheless, it happens, right? Anybody at all got anything they want to see in particular to kick this off this week? Feel free to go ahead and throw it in the chat. Cam with a dovetail cutter. All right, I like it. Rob, do you have a part in particular you want me to use? You can send it to the support email down below and I can get it and we can get it opened up in particular. I mean, it would have been alcohol abuse for sure, but I'm pretty sure if anybody knows me out there, I used to play hockey and I would Zamboni it off the desk if we had to. So we would be more than okay. How you guys doing this week? Been quite the long week over here at jitcadcam. It seems like a million problems came in last minute this morning, and luckily enough, I woke up at 4:30 just hammering through stuff. It also reminds me, how many of you guys are lucky getting all of next week off? Back chamfering tool if possible. No problem. I was one. Yeah, we could definitely look at some back chamfering for sure. Half day Tuesday, off Wednesday. Nice. That's not too bad. Back Thursday, Friday, I assume. You have a Lang vise with a 15-inch dovetail jaw. You have a 15-inch cutter. 30 inclusive. Oh, 30 degrees inclusive. 15 degree. I apologize. Okay. Yeah, I saw that, Travis. It's on I have a smaller monitor. It's only a 17-inch monitor off to the side. So it looked like an inch symbol, not degrees. But yes, all right, we can start with that for sure. Ash, I did see your question there, as well as the back chamfering question from Matt. We'll get to that here in a second. So let me go ahead and switch over. I always love it when you guys bring me content so I don't have to bore you to death with my programming. I'm going to go ahead and save this file and close it out. But if you add a dovetail jaw, I'm going to go ahead and draw this up relatively quick. And you said 15 degrees, so let's go ahead and add our dimensions in here. So we can go 90 minus 15. And then based on how low we want to go, again, if I want to go in, let's say 250. And then depth-wise, let's go ahead and set that to 0.1. Lastly, we need our height and our width. If I'm doing anything wrong out there for who suggested this, feel free to let me know in the chat window. Also, keep in mind, guys, we also have a Discord channel as well if you want to join our Discord channel. But as you can see, we now have, let's just go ahead and go with a 6-inch. As you can see, I've just made that dovetail edge here. I assume this is kind of what you're looking for. Let me go ahead and scroll down, 3 millimeters deep. Technically, the depth really doesn't matter, Rob. I can go in and change that at any time. So we could say 3 millimeters as so. And again, we're still in the working confines of that. So to add that to both sides. Okay, so I see where you're going with this. Okay, cool. Let's go ahead and edit my sketch. I'm going to cheat the system here. What we're going to do is we're only going to make this part 0.5 wide. I apologize for inch versus metric for anybody out there shaking their head. And we're just going to go ahead and mirror this. So let's go ahead and grab this part, mirror it across center. And now we have a dovetail on both sides. Does that look good to you, Rob? Yep. So you're looking at something like that where you're grabbing onto that with a dovetail vise? Cool. So, all right, assume your question is cutting the dovetails, I assume. Correct, Rob? I'll give you a minute to answer before I go assuming things even further. Yep. Okay, cool. So relatively simple. I'm going to create my setup. As you guys know, we don't spend a ton of time on setups unless you guys want me to. We'll go ahead and say fixed size, 0, 0. We'll just make our stock the same size. But if I had to cut these dovetails, of course, the easiest way to do so, one, you would face off your part more than likely. You would come around the outside with an end mill. If anybody knows me, it's going to be a 1/2-inch end mill. But what I'm doing with 2D contour is I'm looking to grab that actual edge for setting my profile for my cutter, right? Now, I grabbed both of those and I held the Alt key, so I just only grabbed that edge. I'm going to highlight both chains here, and I'm going to align extensions, and then I'm going to extend out at least my tool diameter. Again, in this case, I'm just going to go a 1/2 inch at both ends. That way my tool starts off my part, runs into my part, and continues to run past the part, right? So as you can see, we now need a tool to cut this. So I'm going to go ahead and build one because I know almost off the top of my head we don't have anything. So we can go to our dovetail cutter. In our cutter, we have our diameter, whatever we're going to set that to. And then you have your taper angle, of course. So again, whether it's 15 or 30 degrees, if anybody knows me, whatever I type in that window is going to be wrong. So we're going to start with 30, and we're going to use that to our advantage. So with that, we'll go ahead and hit OK. And as you guys can see, we now have our 2D contour down and back cutting at that Z height. Now, if I simulate this, this is where we're going to find out whether or not that cutter is 30 degrees or if it's 15 degrees. And as you're seeing, we, of course, have that mismatch. So I'm going to have to go back and fix that. So let's go back to our tool. Again, we're going to go into our cutter itself. Let's change that to 15 instead of 30. And now you can see it's much steeper. Again, we can resimulate this once I regenerate it here with some hotkeys. You guys didn't know, I've showed this trick a couple of times, and I really have to break the habit of going to my toolbar. But if I hit S, I can make my hot menu here control all of that stuff, right? So again, as you can see, we're running down our part. Again, what we're looking for is that angle matches our dovetail. Diameter of the tool could be adjusted. Our stock and all of those parameters could be adjusted as well. But as you guys can see, that's how you could model your dovetail and how you could go through and machine that dovetail using nothing more than 2D contour and a couple of extensions. I like that one, Travis. Flat end mill fill, right? So again, I hope for the most part, Rob, that might answer your question. Does it answer your question? If not, feel free to let us know. I did see somebody want to do some backside chamfering with a backside chamfer tool. Now, there's going to be a couple of tricks to this, but we can go ahead and walk through that. So we're going to go ahead and finish up the simulation here, and I'm going to jump over to a new file, right? So if I had for a part, I'm just going to make a rectangle here with a hole. We're going to extrude that out. Ah, I see what you're saying, Rob. Yep. What edges to pick for making that? In my opinion, do you find it better to use a 1-inch dovetail or thicker? I would say in my experience, I've never had a dovetail fail due to a 1 inch or thicker type scenario, Travis. A lot of times what I'm looking to do is hold on to the material. As you guys saw me model up here pretty quick, this dovetail width could be even less. Again, it just really depends on what you're going for and the or the capacity of your vise. But I've had to go even smaller so that I could clear my vise jaws. And I mean, I've never had any real problems with it. Now, I would say there's probably a limit on how small you want to go, and you always want to stay to the bigger side if possible. So here's my part. I'm going to go ahead and throw a couple of chamfers on here. Let's go ahead and do chop bottom. Just give it a 40 thou chamfer. Now, as you guys can see, the question is can we backside chamfer inside of Fusion? And well, you can in a couple of different ways. It will be tricky here. Let's go ahead, same thing. We're just gonna do a very simple stock here. Now, again, this is where I may do something like a 2D contour toolpath. And what I can do is I can pick either the upper edge or the lower edge. Now, keep in mind the way your tool is usually defined. It's the bottom left of the tool. So let's go ahead and pull this bottom chain. Let's go over and see what we have for tools, right? So I'm going to go in and we're going to create a tool here again. Now, there's a lot of different tools inside of Fusion, but the real problem is going to be is you need something that has that actual pyramid shape to it. Now, there's nothing by default as you're going to find that's going to give you that profile. Because even if you come into a countersink tool, you'll notice that you don't have an upper chamfer, right? So this is where we've kind of talked about that dovetail cutter already. You may have to define something as a dovetail cutter. Again, if I go back over to a chamfer mill, the same rules kind of apply that if my shaft diameter was smaller than my actual tool, let's say 0.25, what you're noticing is I am getting that profile to some extent, but now I got to be careful of how that's going to interact and making sure all the math lines up properly, right? So again, we have a tip diameter of 0. My actual diameter is a 1/2 inch. Now these are set at 90 degrees, so it is a 45 angle and a 90 inclusive, of course. So when I do my math on this, I am going to have to do a little bit of trigonometry here. Yep, so you can draw them as a form mill also. So again, what I'm going to do is by default, I like to let Fusion do what it naturally does. And as we're going to do here is I'm going to go in and I'm going to do a section analysis so that we can see this, of course. And now looking at that tool path, what I need to do is I'm going to need to offset that tool based on the math of that actual chamfer mill in order to get it where I want it or how I want it offset. So if I needed to do a very simple backside chamfer, again, I could go selected contour. I'm going to make a guesstimate here at like 150. And as you can see, is we could drop that chain down. And guys, I know this isn't going to be exact, but it's more than okay. But as you're going to be able to see is we can actually go in and get that set and be able to use that to our advantage, right? Oh, we need to switch from viewpoint tool to model. Again, we're not quite deep enough based on 150, but as you're seeing here, again, the idea is that I'm going to use simulation to make those adjustments more and more. Now, if you were using a lollipop cutter and had the deburr tool path, that would also be able to achieve what you're kind of doing here. So again, as if we were to go 3D deburr, again, I'm going to define a tool here. Let's go ahead and say that is a, where is it? Lollipop mill. Again, our overall length, let's just go ahead and bump this up a little bit so it sticks out a little further. Yours truly forgot to really pay attention to the math on what was going on. So sometimes the tool doesn't like to partake and actually work the way we want. We could select our edge to deburr. Now, this is something where if we didn't have that edge in play, it could help us out quite a bit. And as we're seeing, let's go ahead and see what we have going on. 3-axis. Again, we can modify things from here. And been sick all week, so it's been quite interesting, but we should be able to get this. Selected edge. Go ahead and change our edge out here real quick and see if we can pull it from the top edge. Yep. As you saw, I pulled the bottom edge versus the top edge, and it didn't like it as well. But with that lollipop cutter, what you're seeing is it's automatically, again, going in and doing what it needs to do to deburr the bottom of that part. Again, we'll get this drug around here. There's our lollipop cutter coming down and around. Now, I could have picked both edges, set a couple of more of step overs, things of that nature. But as you're seeing, again, a little bit different approach. But using the deburr toolpath can be extremely valuable if this is something common in your workflow. I would also tell you that in the event that you find yourself doing this a lot, I did a video on this on Workflow Wednesday, that if we go back to our design and do my favorite thing of copy and pasting, what I'm going to do is I'm going to turn off my original, and then under modify, I can simplify this part by removing features, right? So what I want to do is I don't want to select all. We just want to remove the chamfers. We can delete those. And now you can see I have two models here, one with chamfers, one without. So when I go into machine this part in my manufacture tab, again, using deburr, I can use model. I'm going to add in that modified model, right? And then my edge to actual machining, I can pick that hard edge that we have. And again, we can now use that edge as our center line. Again, whatever our width was, I think we did 40. And as you guys can see, we can go ahead and get that tool to go in and do that chamfer. Let's go ahead and turn off that model and get our original. Again, doing our simulation here. And from that, we'll see it come around. Let's get squared up to this front here. And now you can see that that tool is coming in as much as possible to deburr that edge as it wraps around the cylinder, right? So again, we're breaking that edge with the deburr toolpath with 40 thou. Ash, do you want me to go ahead and show people what you're talking about drawing your form mill? It is a smart way to go about it, for sure. Awesome. So what Ash is talking about is what's called a form mill, and what we can do is we can actually draw a tool inside of Fusion for an end mill. So what I'm going to do, and I always screw this up, guys, so bear with me, is in the case that you did have that tool, is however your tool is shaped, you're going to create that profile, right? So what I'm going to do is I'm going to give myself a tip flat here, and then I'm going to create my center line. So this is a half profile. Again, we're going to go in and we are going to do a perpendicular constraint here. Now I can add my dimensions here. Again, this is 0.26, so maybe we want to go 0.25 just to make this some solid numbers. Again, we have our angles here. This case, this is going to be 45. And from here to here, we would then know this is whatever this is times 2. And then lastly, whatever my shaft diameter is going to be. Let's go ahead and back that up. There we go. Again, if you guys didn't know, this is a trick that I've talked about a little bit, is notice how this is doing the math radial for my dimension. If I was to go to my center line and click it, and then come over here and say center line, now I can go in when dimensioning off that center line, it gives me my diameter versus radius. Let's say this is a 375 diameter. Lastly, we need to give it a little bit of a tip flat. So again, that radii is going to come in very handy for us. And let's say our tip flat is 0.1. So again, drawing our tool, we only need that half segment. Again, the more dimensions you add to this, the better. And as you're going to see here, I'm just going to give it an overall length. Now, the cool thing is because you've set that point, you know where the point is for your back chamfering. One other really neat thing, and I think a lot of people confuse this here, is the ability to go in and create that tool, right? So I'm going to switch to manufacture, and now I'm going to go under my manage tab, and I'm going to go to form mill. So now I need to pick that profile. I need to pick the center line, which is the center of rotation. And now this is where some of you might learn something, is, as you can see, I have a compensation point, right? So this is where, when I select my edges, how those edges interact with this tool. So I could have put a point out here in space, which I would have used as the furthest out point, lowest point down. Or in this case, I could actually use this point on my tool. And now as soon as we hit OK, most people get a little scared because they don't know what happened, right? What actually happened? Well, if I go into my tool library, you can see I now have my form tool. And what I'm seeing over here on this menu, see how big we can make this so you guys can see it here, is my compensation point isn't the bottom left furthest point, right? It's actually the point where that edge is. So when we go to use this tool, again, I'm going to jump back to that lovely block that we did. Let's just go ahead and swap out tool 1. And we're going to go in and we're going to find our form tool wherever we just stuck that. And let's pull that form tool. Now, we don't actually need to do an offset at the bottom. Oh, we got to give it a feed rate, of course. Let's just give it, 60 inches per minute. And we're getting some errors here, but what you're going to notice is now we have our actual tool path. And this is because yours truly, when he set this up, we didn't get all of our information tied to our tool. So don't judge the software. Let's go 60. There we go. We got speeds and feet now. Again, we could generate that tool path. And then I want to make sure, because I am reusing a tool path, we're picking the right edge. No compensation. Awesome. So what you're seeing right now is it's automatically set this down so that when that tool comes in, remember, we are saying pick this edge to be able to do our math from when we want to machine that angle, right? So as you're seeing, although it is the exact point where that tool breaks that 90, we can always use stock to leave to come down and come out a little bit. But this makes your programming much better where I don't have to comp it based on the selected edge. I can actually use that form tool setting. And again, if I wanted to bring the tool down and away, I could do stock to leave. Let's say I want to go -10, minus 0.01, and then minus 0.01 again. And as we'll see again, is if I recycle this and I reuse it, what you're going to see is now I'm not cutting right on the actual tip of that tool. So hopefully you guys learned a little bit something about this. So as you can see, again, using that form tool, it can make this workflow much easier. Once you guys find whatever that workflow is best for you, you could, of course, always turn things into templates and save them to make it really easy to rinse and repeat, especially for backside chamfering on holes. Now, if you were going to do an intersect of like 2 bores, I would highly recommend the deburr toolpath instead. Travis, I see a couple of your questions come through. I'm saving those for Workflow Wednesdays going into the new year. But we will definitely take a look at some of that stuff. Ash, I hope that helps out, and that definitely gives you a couple new pointers where you don't have to use that compensation edge out there. Fusion is smart enough to know that you want to create your toolpath from that point, and then it's compensating the G-code when you post that. Awesome. I see more and more people coming in here. We're already up to almost 40 views. So that is 40 different people have came in and went at some point. I see 16 of you guys out there now. If you guys have any questions at any time, feel free to throw them in chat. You could also send me messages on my support email down in the link. We have a Discord channel. Any way you guys feel to get a hold of us, you're more than welcome to. So let's go ahead and scroll up a little bit. I did see another question about something with a pencil toolpath. Plunging directly into the radius, is there a way to do tangential extensions? Ash, can you send me a part in particular with the toolpath that you're looking at? I'm more than happy to take a look. Nubish, great to see you out there coming all the way from Germany. More and more people coming in as we're sitting here talking and me flabbergasting my mouth out. So if you guys have questions, feel free. Awesome. Ash is going to send us a part. Deep thinker out there once again. How would I add an M00 to a tapping function in a post? Deep thinker, where do you want to put that M00 when you're calling that out? Give you a couple of seconds to respond. Ash is sending us a part file. Anybody else got anything else they want to see right now? So I'm going to put a tapping cycle on this part while Deep Thinker goes ahead and responds. Let's go ahead and just pull a tap out of my library. And I am, again, half-inch fill is coming out. So we're going to go ahead with a half 13. And we're just going to emulate that right there on that part. Just before the tapping cycle and after the tool call up. Okay. So what I'm going to do is, if you guys didn't know, there's some really neat things in Fusion if you're going to do some post-processor edits. What I'm going to do is I'm going to post, and what I'm actually going to do is I'm going to use the export CNC file to Visual Studio Code. This is an Autodesk post, and what this is going to do is actually dump this cycle so that we can edit it much easier in Visual Studio Code. Now, let's go ahead and pull a post-processor this time through. Let's say we were going to run this on, what would be a good one? We've always butchered this Haas post a ton. So what I'm going to do is I'm going to go to the post I want. I'm going to hit the pencil so we can edit it. And then what you guys are going to see is you have to have the plugin installed from Autodesk. But if I go down to CNC selector, I'll have what's called custom. And then I'll see that 1003. So we are now using Fusion, and we've dumped out that actual cycle. So what he wants to do is he at some point wants to do a tapping cycle, and with that tapping cycle he wants to stop somewhere along the way. So as you can see here, depending on where we are in our G code, and I'm gonna go ahead and look over. Did I see a question come in? No, I did not. That was out of the corner of my eye. So as you can see is we have else right here, right drill cycle, you have right probe cycle, you have all of your information inside of Fusion. So again, is by double clicking and with having that ability with the plugin, you can jump to the different lines in different areas. So for example, we have what's called tapping, right? So right now we're doing tapping. There's also left tapping and right tapping. So we got to make sure we're in the right area. But as you can see, this is writing out that cycle right here. So that G98, 84, location, all of that cycle information. So if I wanted to go in and make an M00 happen right before, I could just do a right block. And then I am going to put M format, dot format. Now you don't have to go as far as I'm about to go with this, but this does allow you to plug in all of the information so that you can write this out. And then upon hitting save, I am going to hit an error. And as you're seeing is I have a missing bracket. So let's go ahead and take an evaluation of this. So at 4042, what you're going to see here is on line 4042, we are missing a set of brackets. So let's give this a look real quick. Also been under the weather a little bit, guys. So give me a quick minute to see what we have going on. And what we're going to do is we are just going to do, let's see here if we back up. Try this one other way. So I think it's on yours truly trying to force a right block in a right block. I'm now realizing the kind of day that I've had this week as you're seeing. So what we're going to do is we're going to remove the white block and we're going to type in the M format, and then we'll put our 0, and then we should be able to hit this with an end of block now. Again, we're still not quite there. We're still getting an error, so let's take a little bit more of a look. Okay, we need to do a comma at the end. Let's add a comma, and now Control S has put that M0 down here on this line. So again, yours truly, what I've actually done is I've put this inside that right block, so it's trying to put it all on the same line. So what I'm going to do is I'm going to highlight that, and I was thinking right, I was just on the wrong line, right? We all make honest mistakes, if that makes any sense. So again, we could say right block here. Again, put our brackets, paste in that M format. Again, we're going to go ahead and end to block that and hit save. And now you can see I just populated that M0 above the G98 line. Again, I can jump to that at any time. So it's been a rough week, guys. I have been staring at post processors. My brain is fried. I'm ready for the week to get off. So Deep Thinker, I hope this helps you out. Nothing more than a right block. And again, if you didn't want to do the M format move, you could, of course, come in and you could put this inside of a set of, I don't even know the name for that anymore. And you could type out M0. And what that would do is just write said word. So if you wanted to give this a little bit more detail, again, I'm just going to show you guys that whatever you type in now, that is exactly what's going to be output in your post. So Milan, I see you out there. Any chance to shortly show some samples on how to add bar feed function for Lathe? Yeah, we could definitely look at that. What do I expect from Fusion in 2025? Oh man, that is a trick question for sure. I expect a lot. I think we're gonna see a ton of stuff coming into Fusion 360. Yep, I figured as much, Deep Thinker, that you were looking to do something with tapping fluid. One funny thing is, if you really wanted to, so back in the day, I actually had to do this by hand, but you could put a jar of like, what is it, Molly tapping fluid, and you could go over, and this is where, again, you can get very creative with this, where if you wanted to do M0, or in this case, you could actually say, you know, G00, and then you could go to an XY location, and then you could, again, put another line down below, and you could build out that, like, ability to go do a cycle and dip that tap in that actual Molly P or whatever you guys are using for that fluid. You could also do this as a sub-program call-out. So you could say, you know, if you had it wrote by hand already, you could say M98, P, whatever, E2200. And then, again, right before it goes to do that cycle, it's going to go over and dip that tap. Again, this would be in a sub-program in your controller where it knows where that canister is on your table. So I'm going to go ahead and remove this out of here just because we tend to butcher this post quite a bit. One of these days, it's going to have so many problems. It's going to be easier to start from scratch. So as Milan asked, any chance you could show some sample how to add a bar feeder function to a lathe? Milan, what is your bar feeder call out that the machine needs at the end of the day? I would need to know your bar feeder actual call out, and I could show you how to add it or where you would like to add it and how you can call that. For a lot of you out there that don't know, Fusion now supports bar pull commands. So I would point you in the direction of, instead of using the bar pull, now you could use, let's get back to, I don't think I have any lathe parts pulled up yet. Let's pull out a lathe part. I think we got something simple here. Now, Fusion does have the ability to do a bar pull. Now, in your case, Milan, you may not want to use bar pull, but you could actually use bar pull as the method of calling out when to do your bar push. You could also do something with a manual NC as well. So one neat thing is you could either do a pass-through to call that out, or you could do call program. There's a lot of different ways that I've seen this done. Now, what you're going to want to do is there's going to be some type of code that you're going to call. So what I'm going to do is I'm going to post out a couple of tool paths here real quick. Let's post out these guys. Again, I could use the dumper file to do exactly what we're going to do with post edits here. So I'm going to go ahead and create that as 1001 this time. And now if I go in and I post process, let's go ahead and grab a new post for yours truly to go ahead and get rid of. So let's add a new folder. Free support Friday, delete, don't use. How about that, right? So let's go out to our Fusion library. I like for lathe post, a lot of times we're going to start with either a Fanuc post or a Doosan post, or I should say DN Solutions. DN Solutions, where are you here? So we'll grab that mill turn post, and we're going to copy that over to our local area. Oh, let's change that real quick. There we go. And then we could get rid of this later, of course. So we're going to go ahead and edit this post. Again, you guys have that ability to pull this up. Again, like I said, with manual NCs, you could do your own custom action command to call out when the bar feeder is going to fire. But as you're going to see is we could go through, and what we're going to do is we're going to go to 1001 in our custom, and this is the program we just created, right? So if this is something I want to do on the on-close function, I can easily jump down to my line of code, again, where this M34 is. As you're seeing, down here, we're right block, disable C axis. Again, I could go further if I wanted, interference check. It's all going to come down to where you want to put it and how you want to put it inside here, right? So what I could do, again, is just like we saw, we're going to turn off our cap locks, but we could do a right block. And then let's just say, I don't see Milan answering at any time, but let's say he knows what his call out is. And he's like a, what is it? The LNC bar feeder, right? So he just needs to use some type of M code. And let's just say that's M67 advanced bar. Okay. So we could just plug in M67 right here. Now you could do, again, guys, when you need certain formats, we could easily find where that format is, and I could post it in here, and then we could change out the number if you want to. You don't have to do this. Again, I don't want you guys to go spend a bunch of money to try to force something to happen inside of Fusion. But as you're seeing here is we now have M67 output right here before our M30 at the end of the program. Again, that's going to advance his bar feeder with what he's doing. Now, it is going to get a little different because in his case with a bar feeder, he's going to do something like looping, right? So we're going to go ahead and Control F, and we're going to look for looping. Up here at the top, we have use M98 looping. So if this was true, right? And then with that being true, let's say he's going to do 25 parts, right? So again, his number of repeats is 25. What you guys are seeing over here on the right is we've now auto-generated our looping sequence with M98 Q1 25 times. And when I scroll down here to the bottom, the reason why this is important, the reason why I wanted to plug this in, is we want to make sure that his M67 callout is still happening in this program. And as you can see, it's not happening because we're going to an M99, we're not going to an M30, right? So when we do that M99, for those of you that don't know, we're going to jump back up here to the top, and we're going to run that cycle again, going to Q1, which is N1. Then we run the cycle, and then we jump back up to the top, right? 25 times, then we do an M30. So we lost his M67 here. And what I'm going to do now is we're going to go ahead and jump down. And the reason why we lost that is because this else statement, right? So do this, else do this, right? So I'm going to take that right block back out of here. Again, I'm just going to copy it, then delete that line. And if I come up here and realizing I want to put it after the M40, so it counts the part and then it bar feeds, again, I can simply make my space, paste that in, and hit save. And now what you're seeing is 54 into 67. Again, that advanced the bar feeder, then M99 to jump back to the top. So if we go back to our idea of doing looping, and we now say false, for example, and I'm hitting save here, we no longer get a 67 advance if we're just running one part. We only get that 67 advance when using the looping cycle. So Milan, I hope that helps you out a ton. Guys, I appreciate all of you coming and going inside here. If you guys have any questions, feel free to throw them in chat. I'm more than happy to help you guys in any way, shape, or form. I do see a new ticket came in from our lovely Ash out there. I will go ahead and get that pulled up. In the meantime, why I download that, I'm going to go ahead and hit you guys with the, of course, there's several ways to support us, and you guys are more than welcome to support us in any way possible. Now, the likes, the subscribes, the follows, we appreciate all of it, as well as a lot of you guys out there are sharing our content with other people, and we fully appreciate it. Now, if you guys have found something here today valuable and you want to give a little extra, we do have the Buy Me a Beer program. We conduct custom training. We also do things from on-site training, post-processor edits, full post-processor builds as well. And I just want to put that out there that in any way you guys can even purchase your Fusion 360 directly from us here at jitcadcam. So I'm going to go ahead and pull up this part, and I'm going to go ahead and switch my camera back over. I think that's me. Let me go ahead and close this screen. And we got a couple of questions here from Ash. So first thing is he ended up using a trace toolpath on this part, and then deleted it. Tried pencil. I'm also curious how you would hold this part for Op2. Awesome. So this looks like a structural aircraft part, some of my favorites. And as you're seeing right here is he went in and he created a scallop for that flat area. He's gone around the outside. Now, I assume he's talking about machining this fillet down and around the part, right? So what we're going to do is the first thing I always do is I like to check that radius. Now the radius is exactly 250. So we're locking out here where we could use a 1/2 inch ball and chase around that inside radius of that part. So that would be the first thing I would attempt on something like that, right? So I'm going to go in and we're going to do a trace toolpath. Now the reason why I'm going to do a trace toolpath, as you can see, his part varies in Z as we're going to follow that contour around. So let's go ahead and go 2D. We're going to go to trace. In this case, we've already actually got the 1/2 inch ball in here, so I don't need to select the tool. And the curve selection I'm going to use is I'm going to hold my Alt key, pick the first edge, and then pick the second edge. Now, I can extend this, and this is where we could actually do something kind of neat. We could say, 1.5 extension on the start, and maybe we want 0.75 extension on the end, right? So we're going to come off this part in, down, and around. And as you guys are going to see, that would be simply enough using that trace toolpath to go in and follow that actual fillet and cut that profile. Now, there's a lot of other ways to do this as well. Now, if you're not lucky enough to get in here and actually be able to machine something with the exact same radius as those walls are, we want to follow this profile is what I assume he wants. So if we were to do something like 2D contour, keep in mind, or not 2D contour, let's go for 3D contour real quick. And again, what we're going to do is we're going to leave it basically all default 4/1000 step down, because what I'm looking for is to give you guys that example. As you can see, we're running across the fillet into the wall. And with that being said, is he could have some blending issues from one to the other. Now, in the 3D area, there is a few specific tool paths in particular you could use on something like this. He did attempt this with pencil, right? So what I'm going to do with pencil is we're going to go ahead and grab it, and we're going to go to a smaller ball. Now, this is probably where the issue was, is he may have been using a ball the exact same as that radius, causing those problems. So let's bump down to like a 1/4 inch ball here. And now let's go ahead and see what our geometry is. Again, we don't have any geometry in particular to be picking. So as always, guys, we're going to go ahead and hit OK. And as you can see, we got no passes linked. So let's go back and see why there is no passes linked. So we're going to go ahead and cycle through. More than likely, we have a little bit too big of a step over here. Again, let's drop this down to about 30. And again, still no passes to link. So we're going to go ahead and play around with this a little bit here. In the meantime, if you guys have any questions, feel free to go ahead and place them in chat. So you guys got a little quiet on me out there. Now this is where I start doing stuff and you guys all like start watching me super close, curious how I'm going to figure this out, right? Go ahead and give this a boundary. Here in a moment, you guys are going to see why I don't recommend using the pencil tool. That's for sure. We'll go ahead and turn on contact point boundary because we do have tool center on boundary as well. Still getting no passes to link. So let's go back here again. We can go ahead and change our angle here. Again, more of an angle allows more of that tool to touch. So let's bump this up to 60. Plunge directly into the stock. So yeah, we can go up and we can take a look. There's that trace tool path we did. So I don't see pencil in here on this particular tool path. So again, we're going to evaluate a few more things here. Tool center. Let's go for the good old fashioned tool outside of boundary. Let's just say silhouette. We should get a tool path. And in this case, we're not even getting a tool path on our part. We don't have rest machining or anything turned on. In both ways. Let's see what else we have. Step over. We don't need to limit number of step overs. That's probably one of our problems there. And at all, we're just not getting a tool path. I'm going to go ahead and drag this up a little bit and see if I can force something there. So again, we're just getting a empty set of tool paths. So again, let's go ahead and go for pencil again. Not going to change anything else. And as typical fashion, yours truly completely butchered this before by checking all these boxes, as we always joke about. And as you're seeing is now pencil is working, and it is working with a 1/2 inch ball, not a 1/4 inch ball. So what you're seeing here is we are getting a path, and as he was saying, he was plunging into the part right here. And I can see that for sure. And the problem is going to be is that there's really no control over like boundary overlap or anything of that nature. Again, turning on contact point boundary might not do anything. Let's go ahead and change our step over as well while we're here. Again, we're not getting any changes or any results that are making any different on this part based on all of these settings, right? Now, we did get something here, a little chaotic, a little wild. Again, I really had to force it by changing the limit number of step overs. But again, still the same result. Now, in my opinion, this is where if you're doing stuff like this, the machining extension starts to become your best friend. And the reason for that is if I was to now go into what's called the corner toolpath, this is where you're going to see the magic of the machining extension. And somebody did say, am I excited about new stuff to Fusion next year? Yes, of course. Because even if this wasn't a 5-axis toolpath, which is a 5-axis toolpath, now just this toolpath in itself is crazy because the rest machining, like this would be my big thing for Autodesk. I like rest machining, don't get me wrong, but the rest machining here where I can define a tool. So for example, here we did a 1/2-inch ball, right? So I can go and do rest machining based on a tool selection. And then again, you still have your typical step over, step down type settings. And for the sake of this, let's turn our tolerance up so we get a pretty quick tool. So we're going to let that calculate here. I'm going to scratch my nose. And as you're going to see, this toolpath isn't going to be the best because we did go in there with a tool the same radius as that cutter, right? But if this actual part was cut with a bigger radius cutter, so again, let's say we go in, I'm not going to make a tool. We're going to just grab a tool here. Again, let's go for a 5/8 ball. And now the reason why I'm putting a 5/8 ball in my library is because I am going to cheat the system and grab that 5/8 ball. Now, you could also, just so you guys know, you could adjust your edge of tools too. So let's say we just go with a 5/8 ball. And I'm showing this so you guys can understand the idea is usually your ball end mill isn't going to be the same size as that fillet. But as you can see now with corner, we're going in and out of that corner. We're able to go in and machine that actual and blend our fillet with a smaller tool, aligning that up with everything going on. I see Ash, I see a couple of questions come in here recently. Put it between 2D contour and scallop. Oh, I see what you're saying. With that pencil tool path. I still don't think it's going to do anything. I think that tool path is just a bad tool path on yours truly. Deep Thinker, I see another question come in on the post screen during post creation. I'm looking at the probing and inspection under post property. How do I set this up? What, Deep Thinker, what post are you using? In the meantime, Ash, did you see what we got out of that corner toolpath? As you can see, this would be another way to approach something like that. Is it just the FANUC or is it the FANUC inspect post, Deep Thinker? FANUC inspection. I figured as much. I should have known. All right. So what we're going to do is we're going to go back. We're going to grab that FANUC post. Now, the post he's talking about, there is posts inside of Fusion that have this inspection area on it. And I think you can actually filter by inspection. Go ahead and go all. So all of these posts have probing inspection built into them, right? So everything from your Haas's, your FANUC, Heidenhain, I think there's Siemens, yep, down here at the bottom. But what we're going to do is we're going to go ahead and grab this FANUC inspect post that he's talking about. And we'll go ahead and paste this in here, and then we'll select that. So what he's referring to, as you guys can see, is this probing and inspect area of the post. Now, there's a couple of things. One, commissioning mode. What is commissioning mode? Commissioning mode is when you first run this cycle, it will pause a lot of times to make sure you don't crash your machine, of course. Right? So once you run it the first time, again, and I say that because the probe's going to come down and then it's going to stop your controller and it's going to say, hey, is the probe on? Is the probe above the part? Right? Like it's trying to prevent you from completely destroying your probe. Now, once you do the first time round, you can turn off commissioning mode. And then with that, it'll run clean and free. Right? Now, going a little further down here is calibrated radius. Now, this comes from your controller as well as your eccentricity in X and Y. These are macro values that you have at your controller that you need to plug into Fusion. When you calibrated your probe at your controller, you have to plug this type of stuff in. You also need to plug in your on and off commands, which these are the M codes that are controlling your post. And then, of course, from there, you have your different things like geometry and wear, geometry itself, if you're going to use like workpiece error and all of that. So to go in and set this is if my concentricity was like 4 thou, or actually let's go 4 and 4. And then with that, my probe on command might be 67. My probe off command might be 68. Now that I've gone through and stuck all that information in, when I'm posting, we'll go ahead and have that. Oh, one sec here, Deep Thinker. Probe on is G65 and not an M code. Okay. So we'll go ahead and take a look at that inside the post. So let me go ahead and hit the edit button. And you're saying it is 9832. This is going to write E plus 9832 based on what you're giving me. And then you were talking about 65, right? So macro call G format 65. So it's already doing it inside the post processor. But if we go up to the top, you guys could also see this here if you wanted to dive a little deeper on your end. What we're looking for is the inspection stuff. Gonna get way up to the top. And again, what it's looking for is those values that we're plugging in based on our inspection procedure. Now, it may be hidden a little further down in our post, and I'm pretty sure it is. So sometimes just by searching probe off or probe on, we can find where that property is. Again, properties.probeoff command. This is an M code for you to call up to say your probe needs to turn on or your probe needs to turn off, right? So how do you find the XY macro codes? That is going to be set up when they installed your probe and whoever you bought your machine from. Now, I can say in my past, a lot of machines, it's usually the macro 500, 501, 503, right around there. Now, again, I wouldn't trust that fully on every machine, but I've seen that very commonly on quite a few machines. Matt, I love the comment. Yeah, 100%. I use 3D Contour on quite a few parts. I teach 3D Contour as well. I've gotten out of the habit of the good old flat end mill, Phil, as you guys know me, is using a bull end mill, if you didn't know, does wonders on a part. Again, if you had a part like this and you needed to machine a flat area, a lot of people are thinking to themselves, if I come in here with like a horizontal, we're going to go ahead and kick on our tool orientation to this flat. And if I actually machined this with a flat end mill, so he's got a bull nose here. I think I have one in my shop crib. I always have a flat end mill in my shop crib, it seems. Now, the problem I've seen a lot of people is when you come in and you start to machine something like this with a flat end mill, because it's so square on the edges, it can actually leave like a ring, or it can actually cause like much more scratching on a flat surface. And there, again, that's where you have a flat versus a bowl, where I've started to finish pockets much more using bowl cutters. As you can see, he's got a 30 thou edge radius on this tool. Now, little secret here, even with your roughing, I also use a bowl end mill for that, but I never do more of a step down than the radius of my bowl. So if I was to rough a part out like this, again, I'm going to go up to the top here. If I was using a bowl end mill and I was roughing this part out, I would actually go for pocket clearing. And again, based on that tool, if he's doing a, where was it, 30 thou radius on that tool, I would go in and I would set my maximum step down to less than 30, right? So let's say 20 is what I wanted to go with. And then every time it's now doing 20 thou step downs, it prevents that tool from deflecting quite a bit. Of course, we have rest machining like always, but it allows that tool to also be fed at a much higher rate of speed to machine out that part. Again, because you're taking such a shallow cut versus a heavy step over. Deep Thinker, I hope that answers your question. And Matt, I agree, using 3D does wonders. Now, on a part like this, I think he was looking for something a little different when it comes to machining, of course, that fillet and blending that fillet. Another thing I guess he could have tried was where is it here? The flow tool path. Based on these couple of surfaces. Now, the problem with that is you're going to have the along U, along V, of course. And it's not going to follow down and around that profile, as you can see. And that would be the real problem with the flow toolpath as well. So again, as if we swapped him out to that half-inch ball. Again, we could do a little smaller step over or step down. Oh, go back here. Again, because that ball is so big, that's why we're getting that same effect. So you wouldn't want to 1-to-1 ratio that, of course. There we go. And again, as he's getting down here, you can see we're staying in that U or V. We're not actually following rails or anything around our part. There would also be the ability to go in and use geodesic. Sometimes we'll do some stuff in this part. Now, geodesic is meant for a lot more flatter toolpaths. So again, is you could also go in and there's morph that could help. Again, morph allows you to kind of do a different strategy again, selecting curves, but you're not giving it guide rails, which again could affect what's going on. I'm trying to think off the top of my head, where is it here? I can't remember. Oh, where is it? There is the ability to do where my brain is just not working. So this would be blend. Blend would be, here's your drive surfaces and then your curves, right? So this is where you could set rails to follow between those two rails. Go ahead and delete that chain. Edit this chain. Give her a sec here. Again, blend would work quite well, as you can see, coming down and around on that inside surface. Yep. And again, based on these different things, and Ash, remind me, do you have a 5-axis machine? Give you a second here to response. Neil made the right call there. Neil, great to see you again. Yep. So, again, now that knowing that you have a completely different machine than what you have here, like you could start to talk about multi-axis toolpaths for sure. So again, as you could get into something like a swerve toolpath, that would help a ton. Getting into your steep and shallows, again, we could go and I think some of you guys have seen this, but let's say we want to do a little bit crazier of a system here. So what I'm going to do is I'm going to jump back to design and you'll see why. Let's say we want to create a construction plane. Oh, nope, not there. Off this flat. And now with that being said, is I'm going to throw a sketch on here. And then I am going to place a point off to the side here. And what you're going to see is now, one, I got to turn on that point, is I can use that point to control where my tool comes from inside that pocket, right? So if I go back to manufacture and I do something like 3D contour, 5-axis, and now my primary mode can be from point, right? So I could say, here's my point that I want my tool to always come down through. And with that, we'll go ahead and stick with the 1/4-inch ball, which is fine. Again, I'm going to bump up my tolerance so we get very fast tool paths for you guys. But I want to show you what we get for a toolpath to start. And then when we simulate something like this, notice how that tool is leaned way over. But what I'm really concerned about is the center line of that tool always intersects that point. Yes, we're a little steep here. Let's get the stock out of the way. But as you're starting to see is we can, of course, use 5-axis machining and be able to tilt that tool. Again, taking that tool and almost making our manual tilt to one position. Another thing you could do, of course, is we could now go back to design anytime we needed. We could go to our, of course, when we sketched that point, drag it up higher. Again, going back to manufacture. And upon regenerating that toolpath, we, of course, will get completely different results, right? But again, that tool will be much steeper. Again, staying away from that corner when we're machining. Yep. That's the luck of the draw on machining, Ash. Of course, you could never get the part to do it on the right machine. As I tell everybody, machining is just nothing more than making the right part on the wrong machine. That's all you guys do, right? Awesome. Any other questions out there from anybody? Go ahead and give you guys a few questions. I see more and more of you jumping in and jumping out of here constantly. If you guys have any questions, feel free. Go ahead and post them in chat. I'm here for you guys. Any problems you had throughout the week or any issues? I'm going to go ahead and check. Let's make sure we have no new tickets in here. And also close out that lovely ticket. Awesome. Nobody's texted me on my phone yet, which is usually a good time. Any other questions, guys? Any other things that you want to see in particular? Oh, of course. Live connected part alignment in Fusion. Yes, I have used it. It works quite well as well. The live connection for inspect surface works really, really well also. I will say the only caveat to it, though, is you have to have a dedicated license of Fusion when doing so, right? So what I would do if I was doing it in my shop, and this is just me, is one, hardwire to your machine, the computer you're going to use, and then have a dedicated Fusion license and computer for doing that. And the reason for that is because you don't want to disturb it along its way. Just let it do what it needs to do, right? Ash, no problem. I'm always happy to help in any way I can. Awesome, Neil. Any other questions outside of that, guys? We're closing in on 70 views already. I think the record's like 140 over 2 hours. Or is it that time to pull a 5-minute break? I'll let you guys decide. If I don't see any questions in the next 60 seconds, we'll go ahead and pause for a water, coffee, bathroom break, whatever you guys need, and we'll come right back. Your thin wall question. Which thin wall question? Oh, I see it now. Okay, finishing thin walls to avoid chatter. So the secret to kind of finishing a thin wall is to machine down the part slowly, right? So I used to do this a lot in the mold industry. I'll use this pocket clearing as a good example. Let's say his wall was much higher, or in this case, maybe we're actually machining in a different angle. The theory is still the same, right? Is I would take this and I would section it off, right? So instead of going always from the top to the bottom, I may say highest of selected and go highest of selected. And then I only want to come down maybe a 1/2 inch, right? Now, I would do whatever I could do on this part. We would rough it out. But then I would repeat the same concept with my actual finishing, right? So again, we would do the same thing. And there's a better way for this, and I'll show you guys here in a second. But again, we only want to machine down, again, a 1/2 inch from the top of our part, right? We want to take this down piece by piece or layer cake it and almost like melt it away 1 inch at a time or a 1/2 inch at a time. Now, given that we've set that all up on my 3D toolpath here, I'm going to go in and we're going to say no boundary just so that we're roughing all the way outside of our part. And let's say, for example, here, I'm actually going to go -250. There, we're just doing the very, very top, right? Is you can right click on that first toolpath and then we can go through and start to derive all of our other stuff. So if I wanted to go to contour, again, I have my tool here. We'll go ahead and swap out to that ball end mill. And again, we're going to go ahead and drag that up to the top. And now, as you can see, it's just one into the other, right? But now you can get a little more fancy with this because I could take both of these. And what I would do is I would actually put them into a folder. So you could say, you know, new folder. And then this is the first 0.25, right? So 0-0.25. Drag it up there. Of course, you could put those toolpaths in there. It just makes it a little more organized, right? But now we can duplicate that folder. So I just push Control D. And now we might go 0.25 to 0.375. And you can bulk edit stuff. So if I go in and I could do a compare and edit, we of course can type in things like top height, and then you have highest of selected, but we could actually change that if we wanted to. And in this case, we know highest of selected, and then we have it's based on our model top. Let's go ahead and set our, again, you could search just about anything in here. So you have offsets, right? So again, bottom offset minus 0.25, I could say now minus 0.5 here, right? And then we also have our top offset minus 0.25, because again, we're just basing this all off of what we've done so far. That's actually got to be a minus there. And as you can see, we can then go in, regenerate those next two toolpaths, and you saw me just reuse what I did just a little further down, right? So as you can see, it becomes very quick just to duplicate. Again, go in, do your compare and edit. We're looking for offsets. Again, now we can go from, minus what would that be? Minus 0.75. And then this guy is going to be minus 0.5, right? So once I've already built that strategy by each layer, and again, you can do this with multiple toolpaths in one shot, but just like that, I went in and I did my first, my second, and then my third, and nothing really changed along the way, right? So this really speeds up how I could program that part. And again, with the thin wall idea, I might be worried about what's going to happen. Now, another strategy I've used in the past wouldn't necessarily require me to split everything up this bad. But what I could do is I could start out, and I'm going to copy this guy, and we're going to drag this up to the top, is when I rough out this part, I might use a lot more stock to leave, if that makes sense. So again, let's say we're going lowest. We're going to stick with that good old-fashioned 0. Again, because it's thin-walled, I might leave closer to like 60 thou on the walls and still maintain, that 20 on the floors. And because of rest machining, what you're really going to see here is like we roughed out our whole part. I'm going to go ahead and turn my stock on so you guys can see this. And then we're going to regenerate our rest machining. And now we're only doing a little bit of roughing in this corner. And again, you guys can see that if I turn off my toolpath using F7. So there's my first segment machining down. And then we go in and we do our finishing. And then we move to our next one. Again, as you can see, this would be another strategy to benefit if I have very thin walls or I'm fighting a thin wall chatter situation. How can I reinforce it as I work down my part? Yeah, Matt, you're 100% correct. So if you have a 5-axis machine, and in this case, you would need the machining extension, of course, because you would be doing simultaneous 5-axis, but he's 100% correct where you could go in and you could actually set up and use, where is it here? Multi-axis finishing. And then he's talking about using a barrel cutter or using like a lens cutter, things of that nature. So for those of you that don't know, there is the ability to now do much more advanced cutters inside of Fusion. Again, based on each situation, I'm going to go with this guy right. Oh, nope, that is circle segment oval. Yep, that is the one I wanted. So again, as we have a radius down here at the bottom, maybe that's closer to 3 inch. Again, creating kind of that cartoon bullet shape. Again, we have a lower radius as well. Let's make that a little bit bigger. And as you guys can see, we could use that tool, multi-axis finishing. Again, I'm going to let it just naturally do whatever it needs to do. And we got to select a floor, of course. There's our floor. And let's see what we get. So we're going to have to go and adjust a few things here. And I've seen this one before. If you guys didn't know, shaft length must be greater than flute length. So yours truly set up that tool a little too quick here. So let's edit that. Again, our flute length needs to be greater than the, where was it? Shaft length. Oh, center point of the first radius. So let's make this 2. There we go. And now we should be able to regenerate that toolpath. And if yours truly would turn off his stock, turn on his toolpath. Again, we're getting a lot of craziness right here just because of me forcing this through quite quickly. But yeah, 100%. The actual 5-axis, multi-axis finishing would be extremely beneficial on something like that. Any other questions outside of that in the meantime? So again, we're going to switch out from floors to walls, and let's do blend top and bottom. Grab a couple of walls here and see what we get. And again, now we're getting quite a different toolpath because, again, I just being me. But as you can see, we're now coming in using that segment cutter to cut those walls, right? Cool. Any other questions, guys? I'm going to go ahead and open this up to all of you. We're up to 80 plus people now. Awesome to see. Is it that time to take a fiver, grab some coffee, come back with some snacks? Change out parts in your machine so your boss doesn't yell at you? Well, let's do that. I'm going to go ahead and take a 5-minute break, guys. I will be right back. I appreciate all of you, as you can see. All right, we're back. I see some of you guys dipped out. That's more than okay. It's the holiday weekend. I don't blame you. For those of you still hanging out, anybody else got any other questions? Feel free to post them in chat at any time. I'm happy to help in any way I can. Any questions? Floor is open to each and every one of you. If you guys have any questions, feel free to post them at any time. Anybody watching this after the fact, you guys could also email me via my support email down below on this video. Happy to help you guys any way I can, of course. Maybe we shut it down early. It is the holiday weekend. I will be live next Friday, of course. As you guys know, I will not be doing Workflow Wednesdays the rest of the year for the next 2 weeks. We will start them back up January 8th, of course. As well with the old free support Fridays. I think we're going to continue this through the holiday weekend. We will be live next Friday also. And then, of course, diving into the new year. So I'm going to go ahead and leave this open. Anybody else have any other questions in the meantime? Oh, I see one came in. All right, Jesse, what's going on here? Rough description. Had a shaft that I had extruded a slot through with corner reliefs in the corner to clear a sharp corner aiding part. All right, the deburr toolpath wouldn't select a parameter, but would run. Jesse, can you send me that part file and I can take a look at it? Can you sample machine a multi-axis with a circle oval tool? Nuno, you kind of missed it. We were doing it right here on this part as we're talking about that right now. So we're using a circle segment cutter on this part to come in and machine around these walls. So we were just talking about different ways, of course, to finish the walls on this part in particular. No problem. I mean, feel free to send it. We'll be here next Friday. Of course, you could send in that model. We'll take a look at it. Any other questions out there in the meantime? Probably going to sit here and fight this part because my tool is so large. Get in there and try to machine. Any other questions? Are we shutting this down early for the holiday? What do you guys feel like? Guess I should check one other place real quick. What my work holding would be on a part like this, I think you're going to hate me when I show you, is one, There's really no good way to hold a part like this once you flip it. Now, the live connection and the live inspection data would be your best friend on something like this. But what I personally would do, if I go back to design, and I'm going to create a sketch right here on this lovely flat surface. And as anybody knows me, what I'm going for is just building out a couple of tabs to hold this part, right? As you can see, I can now extrude in a couple of spots to create tabs for this part. And what I'm going to do is, oh, we don't want to join that. So let's back that up one real quick second. And there's my tabs. I'm going to say new body. And I'm going to do another extrude. And this is going to be a two-sided extrude. And as you can see, I can basically replicate my part and hold it up in the air if I wanted, based on how we can machine that out. And now this is my tabs, right? So if I use this and I go back to manufacture, what you're going to notice is, one, my Z-axis would be different because we're now machining it up in the air. But I would use that to my advantage, right? So now this is my fixture. My stock size, of course, is going to change based on the Y-axis. Let's say this is 5 inches now, or let's go 4. Offset from front side. Oh, we got to go offset from back side. 0.1. There we go. So now you can see that is my jig, and that is sitting inside my stock. But when I'm machining things now, Fusion and the ability to avoid jigs and fixtures is automatically going to machine around that part as I get further and further in there to machine it. And then with something like this, I could use that, again, to my advantage. And now that I have it all machined out, I would just come back with something like a 2D contour, of course, cut my tabs off, right? So this is a little different way to think about doing a part like this, but it could be extremely beneficial when machining. Very simply now cut those tabs off. Again, you might split this into 2 tab cutting preferences, but then it's one piece hanging out in the air once you've machined everything off of it. And then you just have this one flat edge here, which should come out almost precise and exact. And then you just tab and split it off. So let's see what we got for a part file here. Is this a tool holder that you sent me, or is this a actual part? So I'm going to do a workflow Wednesday about tools here. To get back over to my other menu here real quick and see on it. Oh, it's a tool holder, huh? Okay. Oh, I get what you're saying. Okay. Give this a second here. Taking longer than expected. Big surprise, right? Oh, that stock is massive. That's why. Here we go. Ash, how's this look as a little different concept to the way you're thinking of doing these parts? So, Nuno, what do you want me to do here? Let me scroll up and see. That's an engraving tool. Okay. Oh, okay. I see what you're wanting. So so in this case of this exact thing, so you're trying to engrave with nothing more than this tip, or are you trying to do this on like a plasma table? Is it an etching tool or what is it? So I'm going to do a workflow Wednesday in the new year about converting tools and all of that from step files. Anybody else have any other questions outside of that? Yeah, it's definitely a little different part. Yeah, I mean, Power Mill at the end of the day is an extremely more mature product on that specific tool there. I'll definitely do some stuff offline with it, and like I said, it's going to be very tricky for something like that inside of Fusion in its current state. So there's no real tricks I'm going to be able to show you at the moment with that. I see Deep Thinker. Can you do a spiral facing on a round part for milling? Spiral facing on a round part. So we got a round part here. We could do a setup easily for milling. Let's do a setup, milling. See. And now you want me to do spiral facing. Are you referring to polar milling? I'll give you a second here to put your answer in. Deep Thinker had a question about spiral facing on a round milling part. Start at the center and face mill out. Sure. But like you're saying is 3D spiral. Again, based on a silhouette of our part. What we do need to do, though, is you have your inside, outside. Again, clockwise, counterclockwise, spiral mode, inner limit, outer limit, right? So in the case of this, is I could leave this as is. Let's say we're going to, what tool are we using here? Let's give this a milling tool first and foremost. And our step over 125. Just like that, you could see we're now doing a milling tool or a spiral tool path that's starting inside, working outside. Now, if we change our boundary from silhouette to bounding box, again, you can actually draw your own boundary here. And now you can see we're, of course, starting further in. We're also diving down, so we would need to adjust that because this is a 3D toolpath as always. Is that what you're kind of thinking out there, Deep Thinker? And pick that top surface. Highest, we'll set this one up. I can fix that. Do is cool. I like that. Ash says somebody is watching the Titans of CNC. Yeah, I mean the 3D toolpath, and I actually did a video on this if you guys haven't seen it. It's the facing video where I use different strategies using like 3D. Again, there's a lot of different ways to go about it, but using 3D toolpaths to face off the hat of your parts so that you don't have weird drops or weird things happen with that part, right? So again, spiral works quite well. You do have to be aware, and I think a lot of people miss this about the spiral, is the inner and outer limit will always get you, right? So if the inner limit was 3, we might actually have to go smaller. I think this part's smaller than 3. Let's go to... Oh, not quite shrinking it down, but what will happen is that outer limit, being much smaller, will shrink up, as you can see in this image. This part is quite small. The actual diameter of this part. Yeah, 250. So it'll keep it from actually going all the way outwards, is why you guys saw me plug in like a large number at the end of the day. There we go. As you can see, it's not going all the way out to the outer part of my part because of that. I see Mitchell with quite a bit here. I'm looking to organize the production of a milled and turned component, specifically cylindrical and hexagonal parts, with threads ranging from M20 to M50. Feature editing. Yeah, I mean, we could definitely visit that in a private meeting by all means. What he's asking about is basically a family of parts and how he can go about creating a family of parts and setting up those models and programming them up quickly and keeping everything tied together and nice and easy. But yes, Mitchell, 100%, we could meet offline on something like that and talk a lot more. Any other questions outside of that, though? Going once, going twice? You know who I haven't seen in here we see every week is Matt Van Loo. Where's that guy at? We're sitting at 99 views. Should I wait until we get one more? Should I start the outro so that you guys all of a sudden ask me a bunch of questions? I think we're going to call it short this week. Well, guys, yet another free support Friday. I appreciate each and every one of you for joining in and posting your questions and the problems that you guys have. And it's always shocking to me that a lot of people are a little worried to ask questions, but when they do, they realize a lot of people have either thought of that question or have ways to work around that. With that said, if you guys are watching this video, it's not what you know, it's who you know. Feel free to shoot me an email down below with the support email at any time. You can join our Discord channel. We're here to help you guys in any way we can and help you guys continue and progress your abilities inside of Autodesk Fusion, as well as helping you with any of the ins and outs that could be a problem. With that being said, I will see you guys next Friday. In the meantime, happy holidays. And for any of you celebrating Christmas, of course, Merry Christmas. Thanks, guys.